Following on from the previous two videos, we got to this stage here. We got to this stage here where I said this will cancel out with this, giving you this. So let's try and understand why this will cancel out with this. So if you get if you look at this bit here, if you get B cross C, so if you get B cross C, that will then give you this vector here, and this is a vector. So if you get B cross C, it will give you a vector. So it would be something I plus whatever J plus whatever K, and then you would divide it by its magnitude. Well, its magnitude would be, let's say hang on. So B cross C would then give us this, and then we would divide it by its magnitude. Let's just say the magnitude is 3. Then divided by 3, then that would then give us the unit vector, the normal unit vector that's perpendicular to the plane. So when you divide it by the magnitude, like in our case 3, in our case it's 3. So hang on. If you get B cross C, it will then give you a vector. So you can think of it as being like this. And then when you divide it by its magnitude, it means this thing here divided by a magnitude of 3. Let's just say whatever, let's call it star, divided by the magnitude of, in our case, is 3 earlier. But let's just say star, divided by its magnitude. So you can think of this thing here as this vector here. So you've got your whatever divided by star, and then you've got whatever divided by star in the J direction, and then you've got whatever divided by star in the J direction, and then you're dotting it with this vector A here. So remember, later on you're going to need to do this. Later on you're going to need to get this times this, and then plus this times this, because you're dotting it, and then plus this times this, and so on. But then out here you've got the magnitude. Don't forget our magnitude is 3 or star in our case. So the dot product will be this times this, but then later on you've got to get this times this as well. This times this, this times this. So you can see that the magnitude will cancel out with each other. So even though you've got this dot thing, if you look at the process behind the dot thing, it would be this times this, this times this, this times this, but then you've got this thing here, so it's going to get multiplied here, multiplied here, multiplied here. So in effect, even though it's a dot thing, which we don't fully understand, it's this. Well, if you look at it, this times this times this, so you can see it cancels out. This times this times this, so you can treat it as normal multiplication, even though it's a dot thing here. The point is that this is a magnitude, this is a magnitude. It will cancel out, giving you this, giving us a new way of working out the volume. Okay.